Okay, so we have the AutoCAD file open, and the assignment says assume the spectator is standing 15 feet away from the front face of a 10-foot cubic volume, and that this face is coincident with the picture plane. Locate the following. So number one says a point 6 feet behind the picture plane along line A, and then transfer this point vertically to line B. So when we see behind the picture plane, that means that we're going to go from this corner of the picture plane to the right. If we see in front of the picture plane, we're going to go the opposite direction and left. But in order to solve this puzzle, we need to establish some units of measure so we can project them towards the center of vision. We know this cube is 10 feet, and I've drafted this at 10 feet. So I just want to copy this line in AutoCAD using a polyline, and I'm going to use the divide tool and select the line and type in 10. So that I can see the 1 foot increments of the 10-foot line. Now, to better display that, let me go ahead and put a 0 here. Copy these down so to turn off my snap. So on and so forth. Alright, so then this would be 1. 2, 9. Let me just move this over. And then copy just one more to make that 10. Let's put these in there quickly. Okay. So now as you see here, we have the 10-foot length of the cube divided into 1 foot increments. The next thing that we have to do is to create a diagonal point, and I've placed my point here. It doesn't matter where you place your point. It will change the look of the perspective depending on the location on the horizon line that the point is placed, but for mine I'm putting it here. The next thing we want to do is then run this from this diagonal point to each of the 1 foot breaks in the 10-foot line. So I'm just going to do that. Okay, it's that, and then coming down here like that. This last one like that. Okay, great. Just delete that line. Okay. The next thing we need to do is create a baseline, and the baseline is going to start from this corner 0 and come down to the center of vision. And then I'm just going to draw it out a little bit here. Take off my ortho. And extend this thing out. There. Great. Okay. Now the way this works is where the baseline intersects the diagonal point lines that converge upon the 1 foot breaks in the 10-foot line, you draw this line straight down perpendicular. I'm going to use my ortho on for this. And it gives you where that point lies within the picture plane, converging towards the center of vision. So then that would represent 1 foot. And that 1 foot could be transferred across all the corresponding lines. So in this first one, it's asking us a point 6 feet behind the picture plane along line A. So line A is there, but we've selected 1 for this one. So to make this easier to see, I'm just going to delete these other lines. Oops, even that's fine. We'll just draw that baseline in again. And I'm going to just extend it this way this time. We'll trim it later. And I'm going to use the 6 foot this time. It's there. So as it converges along that line, the baseline, I'm going to select that point and come straight down. Delete this one. Trim this. And transfer it over because it needs to go to B, first A. And then from A, we'll transfer it straight up to B. And then I'm going to type in just point here and give that the point. And I'm going to change its color so we can see this a little bit better as well. So I'll make that blue. And I'll make these green. Alright. So then the next one says a point 4 feet in front of the picture plane along line C. So if we're going in front of the picture plane, we're coming to the left of the 0 marker. So because I've drawn this to scale, I'm just going to come out 4 feet. And I know that that would represent 4 feet in on the perspective coming towards the viewer. And that should represent the 4 feet. Alright. Now it's the same principle from the baseline now. Or the diagonal point rather. I'm coming towards that, that marker. And I'm going to continue that until it strikes the baseline marker rather. And pull this point straight down. It strikes C first, and that's where we need to go. And that becomes the 4-foot marker in on the perspective line. So I'll go ahead and put a point there as well. Now the third one says a point 3 feet above the ground plane, directly above line D, and 5 feet behind the picture plane. So now we're going in using the measurement markers going on to the right of the 0 marker. So let's divide this first. Let me go ahead and just divide this. Draw another line and divide that, and we're going to do that by 10 because it's 10 square. And there's 3 feet there. Oops, I'm just going to come straight over. So 1, 2, 3, straight over, and directly above line D. From line D, we're going to come straight up, create that first point. And then we need to project this line at this point, because we have it in space kind of here. Think about this as a three-dimensional plane. We need to project this point towards that center of vision. So this one is going 5 feet behind the picture plane. So I'm going to come to the 5-foot marker here and bring it to my diagonal point. And match properties so we can see what we're doing, make sure they're consistent. And from that 5-foot marker where it strikes the baseline, I'm going to come down, first hit line C, and then transfer that point over to A, and then finally to D. Just crossing that line. I'm just going to trim that so we can see. Now I need to figure out where this point is, because it was only 3 feet up from our ground plane and our picture plane. I need to project that depth as it would be into the center of vision. So I'm just going to click here towards the center of vision. Oops. Click here, then go towards the center of vision. And then from the point that we established here, I'm going to come up perpendicular to strike the point and locate it. And then use the point marker here.